Yes, welcome you all for another presentation on electronic devices and circuits. In today's presentation, I would like to bring before you some of the very important information about the transistors. Normally, the transistors can be named as bipolar junction transistors. In short, you can call it as BJTs, bipolar junction transistor. Right? So, by the way, this is our lecture number 7. In this, we are going to see a brief information or presentation about the bipolar junction transistor. This is one of the very important topic or chapter which is to be considered under your electronic devices circuits subject, right? What is a bipolar junction transistor? Okay, what is a transistor? Normally, if you see the electronic component, or otherwise if you see the electronic devices circuits subject, in fact, as far as your academics is concerned, right, as far as your EDC subject is concerned, the basic building block is your, normally it starts from your PN junction diode, or simply you can call it as a junction diode, right? A brief information of about the PN diode, I think we have seen in our earlier presentations. You can refer our presentations or lectures. There we have covered, I think so, definitely, or otherwise we will see in later subsequent presentations, if at all, if we missed anything about PN diode. Right now, right, this is the basic building block actually as far as your academic is concerned. After that, the next very important is the transistor. The next important, okay, topic or chapter is to be considered as transistor. So this is one of the very important chapter from your EDC subject point of view, right? So what is a transistor basically? What is a transistor? What is a transistor? Normally, or otherwise, transistor is nothing but basically it has a family, actually transistors family. In this transistors, you can briefly write as BJTs, means bipolar junction transistors, right? And the second classification, the second type of under this transistor is FET, that is field effect transistors, FETs, and the third category is UJT, that is UJT. These are the three types of transistors actually. Under this transistor, you can differentiate or you can classify like this: BJTs, this is bipolar junction transistors. FET means it is a field effect. Your BJT is bipolar actually. It is bipolar junction transistor, right? Bipolar junction transistor. What is FET? FET is nothing but field effect, right? Field effect transistor, right? And what is UJT? UJT stands for uni junction transistor. It is called as uni junction transistor. So this is the basic three classifications you can classify under transistors family. Right? Today we will see some important information about BJT, the first classification. Right? BJT. Let us consider BJT. Afterwards, one by one, we will see basically. Right? Let us consider BJT actually. BJT is nothing but your bipolar junction transistor. Basically, what are the main features? Nothing but it is BJT. Okay, BJT is nothing but, as we have seen, it is a bipolar junction transistor. Bipolar junction transistor. Okay, so it is basically, it is a 3-terminal semiconductor device actually. It is basically a 3-terminal semiconductor device basically, right? 3-terminal. If you see the physical construction of this BJT actually, the physical construction, let us see, the physical construction of this BJT is normally, it is a 3-terminal device, and the 3 terminals are physically represented like this, right? So this is called the first one is actually, okay, this is emitter, you can say N P N. The middle one you can call it as, this is one terminal. So if you take one end of this N type, okay, N type material, it is a P type material and N type material, means that basically N type material semiconductor bar is considered, in which the small portion will be diffused with P type material basically, so that NPN transistor will be formed, right? So from this structure, 3 terminals will be taken out like this, and this particular terminal is called as emitter terminal. This is called as emitter terminal, right? In short, this can be denoted as E, emitter terminal. And this is the middle one is called as base terminal. It is base, simply denoted by B. And this is called collector. This is called collector terminal and denoted by C, right? So this is what your NPN transistor, right? So N-type material. So the extreme ends, both N-type material. So from this left side, if you see, this terminal is called as emitter terminal, and the right side terminal is called as collector terminal, and the middle one is called as the base terminal. This is the physical representation of a NPN transistor actually. It is called NPN transistor. Normally I can write T by R, transistor. This is the physical representation. Whereas if you see the electrical equivalent, of this NPN transistor, it looks like this, right? You can draw like this. The electrical equivalent is nothing but something like this. This is the electrical equivalent representation of a NPN transistor, and this will be denoted by like this. So this is one terminal, this is the one terminal, this is the third terminal. Obviously, if you see the arrow mark, the arrow mark is very, very important actually. This arrow mark indicates, means it is the outward arrow mark. This represents the flow of current actually, the direction of current otherwise. So as we have these 3 terminals, these will be again denoted in this electrical equivalent as this particular, this is called as your base terminal, this is base, and this is what your collector, and this is what your emitter, right? This is the base terminal, this is the collector terminal, and this is the emitter terminal. If you see, the arrow mark is shown in downward direction, it is downward direction, clear? And what is the bipolar in the sense? What do you mean by bipolar? Bipolar, and if you compare this particular transistor with actually your PN diode, and sometimes this can be also seen like it is a combination of 2 PN junction diode. You can say like that also. Okay, say for example, if you draw the PN junction diode normally, in which we have P-type material and then N-type material, both if you bring together, then there is a junction will be formed between those two. This is called a junction between P-type material and N-type material. This is called junction. This particular is nothing but your anode here, because it is a 2-terminal device only. This is what your cathode actually, right? So this is your cathode. Normally taken as minus, this will be taken as positive actually. It is a two-terminal device only. This is your PN diode, normal PN diode. And if you compare this particular PN diode with the transistor, means that what actually, if you see these two, NP, nothing but it is a one PN diode actually. This is another, again, if you consider the remaining two, this is another PN diode. Means you can say that two PN diode are interconnected to each other. By physically seeing, you can say like that. But electrically, its operation is something different. But physically, for our convenience, you can say that it is interconnection of two PN junction diode actually, right? But the operation, the flow of current is something different. However, the operation or the working principle of transistor is depends on the flow of current actually, right? And one more comparison here is that if you see in PN junction diode, the current means the conduction current or the flow of current is predominantly due to the flow of electrons. Actually, the majority is because of the electrons only you will get the flow of current in PN diode. Most of the time, means that what, due to majority carriers only. Due to the majority carrier, if you see the PN junction diode, the majority carriers basically is the electrons only. Because of the majority carriers only you will get. Normally, as you know that the PN diode can be operated into two operations, right? That is, one is a forward bias direction and second one is the reverse bias direction, right? So in the forward bias direction, this particular positive terminal is connected to the positive terminal of the external battery, and the negative terminal of the diode is connected to the negative terminal of this external battery or power supply. Therefore, plus to this plus connection, minus to minus connection, then you can say the diode is connected under forward bias condition. In forward bias condition, it will be conducted and your current will flows actually. Okay, whereas if you reverse that particular external supply into reverse operation, means if you something reverse that, if you change the polarities, then the diode is said to be under reverse bias condition. So as you know that in reverse bias condition, diode will be in off condition. It will not conduct, you will not get any current there. Means that what, once if diode is forward biased, then only the conduction process will take place, then only it allows the current to flow through that particular device and you will get the current within that circuit. So the diode must be forward biased until unless it is mentioned or right there. Okay, that is what means that what I want to say is that the current required in that particular circuit, wherever is the diode is used in the circuit, is due to mainly due to the majority carriers only, and again that is due to electrons, definitely, right? Now that is what about PN diode in brief. Let come to the BJT, bipolar. What do you mean by bipolar? Bipolar is nothing but the current carrier, the flow of current is due to both the majority carrier as well as minority carriers also. Remember that. So the flow of current in the transistor is due to both majority carriers as well as the minority carriers. Means that both the carriers will be considered. That is why the name bipolar. Normally, most of the people can remember that as we have two junctions, that's why it is a bipolar. No, it is not because of the two junctions. It is because of two carriers, both majority carrier as well as minority carrier. Because of this majority minority carriers, that is why the name bipolar. Bi means majority and minority carriers or the cause for to produce the current. I think you understood. Now, coming to our actual this thing again. Now, this is what the basic physical representation, and this is what the corresponding electrical equivalent representation of a NPN transistor, right? For a NPN transistor, the arrow mark is shown outward direction, right? Obviously, this wherever the arrow mark is shown, that particular terminal is considered as emitter terminal, right? And this is the base terminal and this is the collector terminal. Once you identified like that, and immediately you must represent the corresponding current flowing through those three terminals. Okay, as we have three terminals for this particular NPN transistor, we will have the flow of current through those terminals. So if you see the collector, you will have some current that is nothing but collector current, that you can say I suffix C, collector current. I is the current, C is the collector, I suffix C is the collector current flowing through the collector terminal. And similarly, so this is the base terminal, therefore through this also current flows, I flows, and the current is represented by I suffix B, that is nothing but base current. Clear? This is the base current. Now obviously what is the direction of flow of this emitter current? Obviously it is something downward direction. It is something downward direction, right? Therefore there are three currents are there. As we have three terminals, base, emitter, collector, as we have these three terminals, and we will have three types of currents that flows through those three terminals. Base current, IB is the base current, IC is the collector current, whereas IE is the emitter current. Right now, now let us assume that this particular transistor, wherever is I have drawn now, you can treat it as a node actually. Okay, you consider this as a node. Okay, consider this particular as a node. Then apply your KCL here. If you apply your KCL, means Kirchhoff current law. What is KCL? Kirchhoff current law. If you apply the Kirchhoff current law, what it says? So if you consider any node, so different currents are entering to that particular node. Different currents are entering here, means, so let us say I1, I2, I3, means through this I1 is current reaching to this node, through this I2 is current is reaching to this node, I3 is reaching to this node. These are the entering currents. Now from this assume that these are the leaving currents. Let us say I4, I think so, or otherwise you can say I5, right? So means that whatever KCL says, the sum of entering current at particular node is equal to the sum of leaving current from that node. Means that what? I1 plus I2 plus I3 is equal to I4 plus I5. That's what's your KCL. Means I1 plus I2 plus I3. Means you have to take the sum of the current entering to a node is equal to I4 plus I5. That is what? Sum of leaving current at a particular node is equal to sum of entering current. Sum of entering current is equal to sum of leaving current. If you apply the same rule here, this is the node, means that now simply by observing this particular direction of the currents, now you can say that IB is entering here, IC is also entering here. So IB and IC are entering at this particular node, whereas IE is going out from that. Therefore, by simply seeing this, you can say IB plus IC is equal to IE. Clear? I will erase this. I think you are getting, right? So if you apply KCL here, this particular, then you can say that IB, base current, plus collector current, IC, is equal to, what is this? IE. Means emitter current is equal to sum of base current and then collector current. Remember, this is very, very important formula. This is very, very important. Right? This is what? The very, very important actually. Base current and collector current is equal to emitter current. Right? Now, now this is very important relation that we should remember. Similarly, if you see that this particular, if you see the physical representation of NPN transistor, just now we have seen that N, PN, this is what your N, this is what your P, this is what your N, this is what your emitter actually, right? The middle one is definitely your base, and this is what your collector, you know. Remember that one more important point is that the emitter terminal is heavily doped. The emitter terminal is heavily doped. So this emitter terminal will inject the carrier into the base actually. This will inject otherwise, okay. This emitter terminal will inject the carriers into the base. Okay, therefore emitter terminal is heavily doped. Very important point actually this is. Emitter terminal is heavily doped, whereas your base terminal is, it is lightly doped. That's why it is very thin actually. Okay, this must be shown very thin actually. You can show a little bit smaller otherwise, right? The base terminal is always thin actually. If you perfectly want to represent, definitely it is something, the width is very less actually comparatively collector and then emitter. If you see the base terminal, something, this must be very thin. The base terminal is very thin because it is lightly doped. Emitter is heavily doped. Your base is lightly doped, whereas the collector terminal is moderately doped. Moderately doped. So what this terminal will do? So the emitter terminal will inject the carriers into the base, and this base terminal will passes those carriers to the collector actually. So the collector will collect. That's why the name collector. Collector means this particular terminal collects the carriers from that base actually. That is why the name collector. It will injects and it will passes and it will collects actually. That is the meaning of these the three terminals, right? That is one important point to remember. Very, very important point. Emitter is heavily doped, base is lightly doped, whereas your collector terminal is moderately doped. Very good. Next, coming to this particular electrical representation, as we have three types of the three different names of this terminal, this transistor can be operated into three configurations. What are the configurations? Just I want to tell you very briefly now. In next presentation we will see definitely in elaborate in a meaningful way, but this presentation I would like to give you the brief actually. So as we have three terminals, then particular, this is NPN basically. If you can see that PNP, that is something reverse of NPN only. So if you see PNP, so definitely your PNP is something, this is, so the middle one is something small. So this is P, this is N, this is P here, P in PNP. Again same, this is your emitter, the middle one is definitely base, and this is again collector. Same as PNP. Here, if you see the electrical representation, electrical equivalent of a PNP transistor, what is the difference? Just you show the arrow mark in upward direction. You show that the arrow mark simply in reverse direction, upward direction. And definitely, as you are showing this upward direction, your direction of the current is something reverse of this. All directions will be reverse. Okay, here in a PNP transistor, this is what PNP transistor. This is PNP transistor now. In this you show the current is something, it enters here, IE, emitter current. Once it enters, then definitely what is the flow of the current IB and IC? Definitely they will be shown backward direction, because it is entering. Therefore entering to a node is equal to leaving. Therefore your IB should come outward. It is something coming outward. So here your IC is also going outward. You must show the reverse actually. Previously whatever we have seen the direction in NPN, you just reverse. That's it. This is what a PNP transistor, right? Here also the same. It is entering current to the node. These are the leaving current. In this case also your relation holds good. That is IE is equal to your IB plus IC. Remember that. In both cases, either it could be NPN transistor or otherwise PNP transistor, the relation between the current holds the same, means the emitter current is equal to base current plus collector current. That is true in both the cases, either it is NPN transistor or otherwise it could be PNP transistor. In both cases, the relation gives the same. Clear? Clear. This is what the physical representation, this is what the electrical equivalent representation of a PNP transistor, right? So in both NPN or otherwise the PNP transistor, right? So as they have three terminals, these transistors can be operated into three configurations, right? So before going to the configuration, what is the main application of a transistor? how a transistor can be used or why it can be used. What is the basic purpose of a transistor? The basic purpose of a transistor is that transistor can be used as an amplifier, right? That is the very important purpose of a transistor. A transistor can be used as a amplifier. Transistor can be used as an amplifier, can be used as an amplifier. So this is the basic important purpose of a transistor. It can be operated as, it can be used as an amplifier in analog circuits. This is the application in analog circuits. Whereas if you see in digital circuits, the transistor can also be used in digital circuits. That can be used in digital circuits, right? In digital circuits, it can be used as a switch, right? In digital circuits, the transistor can be used as a switch, whereas in analog circuits, the transistor can be used as an amplifier, right? What is an amplifier now? What is an amplifier? What is an amplifier? An amplifier is a device which amplifies the input signal, right? Amplifier is a circuit, or amplifier is a device which amplifies the input signal. What do you mean by amplifies? That is simply nothing but, simply for your brief understanding, I will tell you. Let us say one small box. Let us say it is some electronic, or it is an amplifier, you can say. Let us say amplifier circuit, let us say. It is an amplifier circuit. This is what your input actually. Let us say this is what your input, output. What is amplifier now? How this amplifier? So I am telling you that the transistor will be used as an amplifier. Means definitely this amplifier circuit consists of transistors here, definitely. Either it could be NPN or PNP, whatever it is. Now, if you take your input as a something like this, a sinusoidal signal of having peak to peak magnitude 5 volts, let us say the peak to peak amplitude is 5 volts. So this much of the input signal having this much 5 volts peak to peak input a signal of amplitude 5 volts, you are passing, you are giving as input to this amplifier. Then what happens at the output? Definitely you will get something more amplified signal, means something, it is something more than 5 volts. Your output must be more than 5 volts. More than 5 volts, it must be greater than, means this is the small signal, you can say. At the output you will get the large signal. The amplitude is more, maybe 7 volts, maybe 10 volts, whatever it is, depending on the type of the transistor and depending on the circuitry which you are using in that circuit. Based on all these things, you will get something more amplitude signal or amplified signal. So once if you get at the output, the amplitude is more than your input, definitely you can say that your circuit is working as an amplifier. Say for example, if the input is 5 volts, then at the output also we are getting the same 5 volts, then in that case simply you can say that something wrong with your circuit. Somewhere is something wrong. It could be transistor, okay, it could be any other electronic component which is there in that circuit. Something goes wrong actually, then only you will get, right? Or otherwise even sometimes you will get at the output the amplitude something which is less than your input also. In that case also you can say that something goes wrong in something went wrong in your amplifier circuit. The condition is that you must get the higher amplitude than input. If you get that, definitely you must be very happy, means your circuit is working as an amplifier, right? Therefore that is the basic. Therefore in this way you can say that in this way you can give the definition for amplification like this. A amplifier is nothing but a device which converts the small signal into large signal. You can give this statement also, this definition also. A device which converts the small signal into large signal, that is called an amplifier. That is one kind of definition. Now you can give the another kind of definition also. A device which converts the weak signal into strong signal. This is weak signal, most of the time it can be called as a weak signal because the amplitude is less. That's why it is called as a weak signal. Now after amplification, you will get more amplitude, amplified signal. Therefore, it is called a strong signal. Therefore, weak signal is converted into strong signal, right? That's so in that is what the amplifier definition. So the amplifier converts weak signal into strong signal, or small signal into large signal, right? That is one important definition of amplifier, right? Well, one more important definition, one more important point I would like to mention here is that as the signal is very low here, as the amplitude is very less, it is a weak signal, we are calling it as, or a small signal. And as the signal is very small, see that its impedance is also very small. Okay, its impedance is also very small. And as at the output, if you see, as the amplitude is more, and we are calling it as a large signal or a strong signal, obviously the output impedance is more. So here the input impedance you can call, the input impedance is something less, whereas at the output impedance is very high for an amplified circuit. So obviously you can check in your experimental things also, right? So before amplifying, see that what is the input impedance, and after amplification, see the output impedance. Your output impedance must be high, it must be higher value than your input impedance. Then you can say that your circuit is good, your circuit is working as an amplifier, right? I think you are getting the points, right? These are what the basic concepts required in order to understand the concept of the transistor. Okay, so this is what I think. It is quite enough to stop here this particular presentation, and I hope that you are understanding well and you are getting the information, right? So in the subsequent presentation we will see the configurations and we will see the continuation part of it. It is a very lovely topic actually, you definitely will enjoy this. And afterwards we will see the extension part as I have discussed in this presentation. The complete picture I will explain you in subsequent presentations, and the simplified, I mean there are certain models, low frequency, high frequency models are there. Okay, that we'll see in the next presentation, right? So with this I thank you all, and thanks for watching this, and definitely I request you all to give your observations and your feedbacks and your comments and your liking and disliking. And I request you all that you definitely should, you can share to your friends, because I want to bring this particular things to reach every student, maybe at a graduate level or postgraduate level, at a diploma level. Definitely whoever or searching or seeking to know the information about transistor or the basic concepts of these subtopics, and I want to I wish that to reach this particular to every student, every corner of the globe, across the globe, right? So thank you, and with this I finish off today's presentation, right? Okay, thank you, have a beautiful day.